So this is just going to be a quick update to our quadrilateral family tree. In my previous videos on this chapter, we've been using this family tree that has kind of three main branches. The quadrilaterals branch out into trapezoids, which are a separate kind of shape, and then kites with the rest of the parallelogram family connecting through the rhombus. Now, a lot of these pictures don't even connect kite and rhombus. They have this broken here. So there's kind of two main ways of thinking about quadrilaterals, and it's just down to the definition and how we choose to define a shape. So let me actually present this as if we break this connection. So I know it's not exactly what was in the other videos, but let's break this. Then say we have three separate branches. So we have the trapezoid branch, the kite branch, and the parallelogram branch. Now, a lot of times they define shapes this way. In fact, our textbook does, where it says this has exactly one pair of parallel sides, and where a kite has two distinct pairs of congruent consecutive sides. So the reason for that is to kind of separate the shapes and say this is a kite and it's fundamentally different from the things in these other branches. And this is a trapezoid and it's fundamentally different from the things in these branches. Now, I don't agree with that, which is why why we have this video and why we changed models. So when you do that, you have the idea that a rhombus is never a kite or a trapezoid because those branches are disconnected. So it's kind of nice for sometimes, always, nevers. But when you really get into what makes these shapes interact and what makes them what they are, their properties, it doesn't really make sense to separate them because the properties flow from shape to shape. We saw with parallelograms that these two parallel sides, two pairs of parallel sides, get passed down to the rectangle and the rhombus. They also have two pairs of parallel sides. They also have some other properties besides that, but all of the properties from a parallelogram get passed down to the children shapes. So what we end up with is the properties of kites get passed down to a rhombus, and the properties of trapezoids get passed into these other shapes as well. So I'm kind of have switched from this model, which is exclusive. So it says this is separate, and these are three completely separate branches that don't have any connection, to this more inclusive model where everything is one big happy family. And the reason that we made this switch is because there are properties that get passed down along these missing arrows that aren't over here, which just makes sense that it's coming from that shape to that one. So excluding it and saying, no, this isn't allowed to be one of these makes very little sense since the properties of this shape pass on to this one. So, for example, the kite is the first place that perpendicular diagonals appear. So this has diagonal 1 perpendicular to diagonal 2. Well, the rhombus also has that, but in the exclusive model, it kind of just says the rhombus just gets that out of nowhere. It just appears at the rhombus. But it really doesn't. It's a property of a kite, and that gets passed down, so the rhombus also has that property that its parent shape, the kite, had. Now, it also has the things from the parallelogram. It has the two pairs of parallel sides, and it has the two pairs of congruent opposite sides. So the other thing I like about this is here, opposite sides have to be congruent, right? So we have these two and these two congruent. But over on the kite, we have consecutive pairs of sides are congruent. Now, if you put those together, and we look at, say, this side right here, and I say, well, from the parallelogram, I know the one opposite has to be congruent, but I know from the kite that one of the consecutive sides has to be congruent to this. Well, if I make one consecutive side congruent, then the parallelogram says the opposite side is also congruent, and we end up with all four sides congruent. And really, that's just a synergy of these two properties that say opposite sides are congruent and consecutive sides are congruent, so we end up with all sides congruent. So it's just a natural evolution of these two shapes combining that creates the properties of the rhombus. So that's why I like this inclusion, and why even when we were on this model, I had chosen one where the kite is connected to the rhombus, even though our textbook defines it as two distinct pairs, to where a rhombus and kite are fundamentally excluded from each other. Now, why I'm switching to this and including also these arrows from the trapezoid family is we get some properties from that pass down from trapezoid to parallelogram. So by having one pair of parallel sides, we get this idea that these two angles are supplementary and these two are supplementary. That gets passed down here and enhanced by the parallelogram by now having two pairs of parallel sides and both, like basically all angles, all consecutive angles are supplementary. Instead of just these two pairs, we have all four pairs are supplementary. But it is basically an identical property that just got enhanced by making both pairs of sides parallel. Likewise, for the isosceles trapezoid, an interesting property appears here that the diagonals are congruent. So if the diagonals are congruent here, it makes sense that when the rectangle also has that property, that it got passed down from the trapezoid. And if we think about diagonals of a parallelogram, they bisect each other and they bisect each other. That's it. So with a rectangle, they're overall equal in length because of this side, and they bisect each other because of this one. So that's why we end up with this property in the rectangle, that all four of these half diagonals are congruent. So basically, also from the isosceles trapezoid, we have a similar thing to what we saw with the rhombus. So here we have base angles are congruent. Those are consecutive. But over here, we have opposite angles are congruent. So if you think about that, and we set this angle congruent to both this one and this one, once we have three congruent angles, now we have to have all four of them be exactly 90 degrees. So the constraint of having these opposite angles congruent and these consecutive angles congruent combines to give us the idea that this is going to be all 90 degrees and all congruent angles. So these properties getting passed in from the kite family and the trapezoid family is why I prefer and teach it as this being one big inclusive family instead of excluding these side branches. So hopefully that helps make it clear why we're doing that and how those properties flow down through those shapes.